Hello there. After comprehending all the theoretical background of process design, we are moving to the second concept concerning the business composability. The core of this section has to do with the fundamentals, the principles, and the benefits that composability has to offer in designing the business processes of a cutting-edge technology corporation. Then we will focus on the concepts of modularity and containerization to better understand the characteristics of a composable company. First of all, we have to mention that the concept of business composability is not new to the business world. As an idea, it has been almost a decade since IBM first introduced it in 2014, but it was in the pandemic period of COVID-19 that it became famous and helped many businesses to grow against all odds. Actually, business composability enhances a specific direction where companies try to combine much more agile business models with flexible digital architecture and to adapt to the evolving needs of their customers. So, what do we mean by the term composable business in the first place? We can assume that business composability is a building block that helps you adopt the changing business dynamics. Darryl Plummer, a distinguished analyst and Gartner Incorporated Fellow, claims that composable business is a natural acceleration of the digital business that organizations live every day. It allows organizations to finally deliver the resilience and agility that these interesting times demand. Melvin Edward Conway, an American computer scientist, computer programmer, and hacker who coined what is now known as Conway's Law, states about composability that the way an organization structures its software mirrors the way how the organization is structured. When we talk about composability in business, we are referring in creating an organization using interchangeable blocks such as technology, mindset, and process. Whether we try to illustrate these blocks, it is like having Lego pieces that any business can easily rearrange to fit in any situation. Certainly, composability allows companies to break down monolithic applications into several discrete components. Each of these components can be built, scaled, measured, and maintained independently. This, in turn, gives businesses leverage to efficiently adopt new technologies and processes. That is ascertained by the fact that if an organization builds a monolithic software, it will be based on a monolithic structure which is not efficient or agile enough to compete in the modern market. But if it redesigns its organizational structure to promote smaller and distributed teams who get the authority and power to design, build, and change modular pieces of software, it will become more agile and competitive. That's what composability is all about and how it fits the interpretation of Conway's Law. To sum up, composable business is a framework based on the idea of composing applications by assembling and combining business components instead of starting from scratch for every development project. In such a way, a company can accelerate the time to market process and adapt much faster to external or internal changes. According to Gartner Incorporation, there are 4 core principles that will help businesses become composable. First, there is the ability to discover and understand design opportunities and components in order to guide, track, and secure change. Through discovery, you gain more speed and you can act faster when a change takes place in the business domain you operate. Second, you can achieve greater agility by partitioning a domain into managed components. Modularity makes it easier to scale, measure, and control change by moving interchangeable blocks in an agile manner. Third, there is orchestration, which can lead to better leadership. This principle is about prescribing and negotiating interactions between components. Through orchestration, you can combine all business functions and adapt to the change even faster. Lastly, you can achieve resilience through autonomy. You can maintain integrity of change by minimizing dependence of components from each other. Focusing on independent business units clears the path for better agility and resilience development. To better understand these fundamentals of business composability, let's have an example. If you want to invest in e-procurement to grow your business, then you should first do research and explore what has changed or evolved in e-procurement due to the outbreak of tendering platforms in the last decade. Imagine you have found that e-tendering is extremely trending in your business domain nowadays. In such a case, you can make immediate changes in your e-procurement blocks, like supply-based segmentation, request for quotation, sequences, etc. Business composability provides a complete picture to adapt a new change in the business organization. Other than that, it is important to make it clear that it's not finding the right technology that promotes modularity, reusability of autonomous components, and all the characteristics we mentioned earlier. Although the fact that technology plays a significant role in the specific management structure, business composability implies a new operating model that impacts both the people and the processes into an organization. Based on that, in order to be successful, organizations need to consider the three pillars of a composable company. The first one is the composable thinking. Businesses first need to work on a composable mindset. It is all about understanding what new things can happen in the future, predicting what your business needs to adopt, new changes, and creating a flexible infrastructure. It also focuses on the philosophy of modularity and preparing for future possibilities. An example for a composable mindset would be brainstorming information about how the business industry would evolve in the next few years, or how much the customer's needs and expectations would change in the years to come. This kind of brainstorming would reveal all the market forces and dynamics that would influence your business in the future and give you all the data you need in order to make all the arrangements of assets and adopting the right modular philosophy in your organization. On the other hand, composable thinking alone doesn't work if you don't establish a composable architecture where the different business elements dynamically evolve to create new value. Nowadays, as digitalization has changed the working environment for most business industries, the business processes should be designed to deal with any emerging uncertainties and continuous changes. A typical example to demonstrate the need of composable business architecture is the COVID-19 pandemic period, where the businesses that were not designed to adapt to change their working conditions either shut down or lost productivity in remote work. No one predicted that in the years 2020 and 2021, the need for virtual workplaces would go so high. Whoever adapted quickly to the new circumstances managed to overcome it with minor losses. That's why businesses need to remember that they can't predetermine systems, workers, or processes for a single purpose. They must build a business architecture that can adapt to any situation. The third pillar of composable technology, which merges the other two pillars using the right technology assets and capabilities that promote the use of modular components, reusability, and where assembly and reassembly are automated. It is true that nowadays every business uses technology, from its simplest form of compact customer relationship management to more complex systems. Once more, it is important to highlight that technology itself must be composable to be able to run a composable business. If the business toolkit you possess cannot change, evolve, or scale up according to the market changes, then you cannot adopt the philosophy of modularity. Concerning the composable technology pillar, technology executives must push their companies forward to iterate technology to better analyze workflow, share data across systems, and keep people connected in the remote environment. Today's working environment is changing on a daily basis. Running a composability business model will help you achieve the mostly wanted flexibility and to run your business operations smoothly. Besides that, there are several benefits that turn out to be useful. First of all, composability allows businesses to be more agile and responsive to change, which is essential in today's fast-paced world. Many business leaders have missed out on many business opportunities because they failed to make necessary changes on time, or they didn't have the right vision and tools to adapt to the changes faster. Whether you want to expand your business scale, there are always risks that you will need to confront. Business composability will contribute to leverage modularity and mitigate all risks lurking around these changes. Sometimes the need for changes is inevitable, either because the customer's needs are changing or new market trends appear. By using modular technologies, companies can swiftly test the new market dynamics and find a way to gain more profits. Additionally, composability makes it easier for businesses to connect different parts of their operation, improving productivity and communication. The composable business architecture supports an open application ecosystem. This allows companies to select from best-of-breed innovations. The best thing about composability is you don't have to invest in every individual block. Instead, you can get pre-made kits that can be basic framework to build onto as desired. Additionally, incomposable systems are more reliable as faulty components can be replaced without affecting the entire system. In a company, there are multiple departments, contracts, and people who work separately to achieve its goals. In that sense, business composability is responsible for streamlining the entire workforce and preparing them for the change. By assembling the right combination of applications and services, companies can optimize their operations and get the most out of their resources, reducing the costs and improving performance. Business composability can be applied in your organization at different stages. Leveraging composable business blocks, companies can create cross-functional teams to set up an agile work environment. Subsequently, composable teams can adjust themselves during disruptive changes to achieve their specific desired results. In modern workplaces, digital environments are quite complicated and fragmented. Today, employees use various software to run their daily operations and provide better customer experience, such as accounting software, customer relationship management software, and others. Composable software can help to simplify the training and software walkthroughs and provide technical support to employees. In the past few years, IT infrastructure has enormously changed from hardware architecture to virtualization. Therefore, IT managers need composable IT infrastructure to compose data into virtualized infrastructures. Composable infrastructure is a method to manage physical and virtual IT assets, finding new solutions to allocate them in a more cost-effective manner, such as purchasing software licenses due to the flexible nature of the platform. This infrastructure offers a set of resources to modern IT teams in order to meet the needs of business applications. To sum up, with composable business, you gain the flexibility you didn't have with monolithic applications. You're able to adjust quickly to any market changes that may occur, and you gain much more resilience and agility as a business entity. In the post-pandemic era, the business environment demands high agility and visibility to shift sourcing, manufacturing, and distribution activities. Research has revealed that supply chain resiliency will be a top priority for many years. Other than resiliency, a supply chain also needs flexibility and agility in order to optimize its overall performance. A modular system is an excellent structure that supports these factors and accelerates a robust supply chain strategy. In order to understand how a modular system can lead to a resilient supply chain, first, we need to analyze what is supply chain resilience and what are the benefits for a resilient supply chain. For the last decades, when experts talked about supply chain efficiency, they often indicated lean manufacturing, high throughput, and just-in-time inventory policies. The major disturbances that occurred in many supply chains in the last few years with the pandemic have revealed a lot of weaknesses and several issues about supply chain robustness. What came over the surface was the lean management works to optimize inventory levels to match current conditions, but at the same time, it causes the accumulation of complexity costs while it doesn't hide any inefficiencies. This is where modularity comes in order to support the lean management philosophy without accelerating the cost of complexity and providing a resilient supply chain which can handle external disturbances and still operate efficiently. With shared modular systems, a company enables flexible assembly lines that can effectively balance capacity with demand. Additionally, by having fewer variants of critical components, a company could have more efficient buffering and multi-sourcing. For instance, referring to harmonization of components, if a component cannot be sourced from a specific location, region, or supplier, it could be provided by another region, supplier, or from safety stock. Talking about multi-sourcing, we need to mention that local supply of high variance parts is more cost-effective than missing sales or losing customers. Furthermore, standard interfaces enable expanding the available options on the supply base without adding the cost of complexity. Last and most important is that you always need to keep buffers for critical components. In order to achieve supply chain resilience, a company must assure that, under any circumstances, will always have a constant flow of critical components throughout its supply chain network, for it is a must in this new global environment. So, what is modularity after all, and how modularity contributes to new efficient supply chain networks and business structures? What does academic literature indicate? According to Gielenskip and Martin, modularization is the activity of subdividing a system of products into modules. The process should first take the customer needs into account but also the needs that are driven by technology and company strategy. They also define the term module as a functional building block with specified interfaces driven by company-specific strategies. Gartner and Sean, continuing the work of other researchers, refer that the idea of modularity is to build a complex system from smaller subsystems as modules that are specialized on a set of operations and interact with each other through interfaces but can be removed or recombined in order to obtain new configurations without losing a system's functionality. The authors demonstrate the automobile industry, which provides many examples of modularity. For instance, Volkswagen Group made heavy use of a single modular platform, so-called PQ34, on several different cars such as Volkswagen Golf, Audi TT, Seat Leon, Audi A3, and the Volkswagen New Beetle. From a service perspective, some great examples of service modularity are coming from the airlines industry, and specifically from low-cost airlines such as Ryanair and EasyJet, where services can be combined or withdrawn depending on the customer's choice. As about the business modeling literature, Aversa, Hayfliger, and other researchers mention that the concept of modularity has gained considerable traction in technology studies as a way to conceive, describe, and innovate complex systems such as product design or organizational structures. Modularity has frequently been discussed from several academics for the purpose of gaining strategic flexibility in terms of an organization's ability to swiftly respond to environmental shifts by reconfiguring business systems and redeploying resources quickly to new course of action. More specifically, studies have shown that modularity generates strategic flexibility because it enables the production of large product variety and the speed of bringing them to market while maintaining low costs. This is the reason what makes modularity attractive for a large variety of environments, such as mass customization. Gillenskip and Martin also indicate that there are 3 strategic reasons to isolate a module with interfaces. The first is to enable future development without affecting surrounding modules. The second is to enable flexibility to configure the product to specific customer needs. And the third is to enable commonality and stability over time for modules that will have a positive effect on the supply chain. It is vital to align the concept of modularity with the supply chain strategy in order to have the maximum effect on the overall performance. As modularity is about decisions, competencies, and their dependencies, there are different modular strategies depending on what your long-term goals are. If you want to have product leadership, then you need to invest in capability. In this strategy, the competence could be a core technology development in the module internally and manufactured in-house to keep it close to R&D. The other options are to find a strategic partner with the desired technology and make a strong alliance, or one who will innovate with you. Make or buy decisions for performance-driving modules should always be carefully vetted to ensure development speed and mainly for the protection of unique value and your intellectual property rights. If you want to have customer intimacy, trying to satisfy the demand, then you need to invest in flexibility. On such an occasion, you need to have different module variants that can fulfill all the customer's needs. Although it is difficult to manage such business models due to the fact that the need for accurate forecasting and information sharing is absolute, the business is rewarded with increased market reach, and revenue. Last, if the goal is operational excellence and having a safe and stable business environment, then you must focus on efficiency. Stability always pays off in the long term. To achieve such a strategy, you need to minimize complexity as much as possible in production procedures. In such a strategy, you can minimize all the risks and focus on all issues that depend you achieving an exceptional business performance. As we mentioned before, it is very important to correlate the module strategies with the overall supply chain strategy. If that doesn't happen for several reasons, then the organization's performance outcome won't be ideal. One of the most common mistakes that occurs in modular supply chain management has to do with the production volume. In order to achieve economies of scale and be more efficient, you have to produce large volumes of the same modular component, assuming that the customers will keep buying the specific product at the same pace. That validates the operational excellence modules and efficiency strategic goals that we mentioned earlier. Nevertheless, the modules that are about to change frequently based on the customer's needs and demands with different performance levels, such as quality specifications, cannot be massively produced and at the same time being cost efficient. It is likely to end up with excess inventory and bear all the costs that entails it. What usually happens in the industry is that there are many production lines that produce different product components. That's not the ideal case for mass production. Another issue concerning the production procedures is having batched production process and poor responsiveness to actual external demand, in addition to extended changeover times between products. That leads to long lead times that are damaging the production sequence, resulting, in the end, in the lost sales of the customers not having the tolerance to wait. Turn to your competitors to satisfy their needs. Another inadvertence that often occurs in business is when the market demand starts to decrease. Many companies tend to insource several purchased parts that are used to outsource in order to fill the scheduled capacity. This approach endangers the initial planning of the whole supply chain concerning the make or buy decisions. It is not easy to switch from outsourcing to insourcing procedures and vice versa. There are several parameters that we need to take into consideration in order to decide what to outsource and to whom, and what to keep producing in-house. The make or buy dilemma is one of the most important subjects in procurement and supply chain management. The outsourcing issue leads us to another flaw that many companies do. Producing components in a non-modular integrated design is rather a complex procedure. Many companies do not realize how much this complexity factor impacts production efficiency due to material shortages, high inventory levels, and low utilization of production equipment. In order to handle the complexity of a non-modular product, companies often resort to outsourcing. But this is not the solution, since the outsourcing supplier will inherit the complexity and charge a lot more besides his margin, the raw materials, and his expertise. Once again, it is important to mention that it is mandatory to align the module strategies to the supply chain strategies in order to avoid all of the above usual mistakes. Concerning the manufacturing flexibility, it is worth mentioning that an important advantage of product modularity is that it enables the production of a large product variety while maintaining low costs. Modularity composes a basic component in flexible manufacturing situations. Additionally, it shortens delivery times due to the fact that the configuration of the final product occurs out of modules made to stock and with high work content. Furthermore, since modules have standardized interfaces and are self-contained, they can manufacture simultaneously and independently of each other. This is how the tool of delayed product differentiation comes in place. Delayed product differentiation is often regarded as a principle for the reduction of complexity in operations, which leads to the achievement of large product variety at low costs. But what is delayed product differentiation and how does it work? With delayed product differentiation, you can postpone the point of differentiation as late as feasible in the supply chain. One of its main advantages is that it reduces the company's need to carry inventory of differentiated products subject to demand uncertainty. To the contrary, it carries inventory of undifferentiated products which are converted into finished products late in the process, when it can use more accurate information about the demand for each finished product. This technique results in a shorter lead time while the amount of safety stock that the firm needs decreases and the cost of excess inventory and shortage decline. The capability of delayed differentiation can be developed by redesigning the production process for the products to have common modules in such way that the differentiation occurs later in the process, and redesigning the supply chain so that differentiation tasks can be pushed as close as possible to customers and the end users. An example of delayed differentiation could be the assembly process of a mobile phone. Mobile phones have modular architecture in which there are the following components: Central Processing Unit, CPU, RAM, random access memory, battery, visual display, and several other components that can be considered as independent modules. In effect, each component performs a specific function and has specified interfaces to the CPU, which is the basic component. Furthermore, each module can have many variants. For example, RAM variants can be differentiated according to their memory capacity, so that two CPUs with memory capacity of 4 RAM and 8 RAM are two different variants. Due to the modular product architecture of a mobile phone, it is possible to state that the variants of each module are assembled at one sub-process. Additionally, suppose that there are no sequencing constraints in the assembly procedures of the modules mentioned above. The delayed product differentiation technique suggests that variety proliferation should be kept at a low level. In other words, the increase of variety from one sub-process to another should be maintained at a minimum level. To illustrate all the above, we assume that we have one CPU type, two types of battery, for instance 5000 mAh per hour and 10,000 mAh per hour, three types of RAM, for instance 2, 4, and 8 gigabytes, and four types of visual display. The concept of delayed product differentiation is that the optimal assembly sequence would be to start from the basic module, CPU, and then to assemble successively the battery and the RAM, and finally the visual display. In this way, you can always stall the finalizing of the product, gaining more time to gather more accurate information about the actual demand. When we are talking about containers, what is the first picture that comes into our mind? There are some massive storage crates, huge metal boxes, stored in ports all over the world, containing all the goods that travel around the globe. As Avi Meyer says, you are not too far from the truth because computing concepts aren't too different from real-life concepts. Just like physical containers make the transportation procedure much easier and convenient for all kinds of goods, the same occurs to software containers that simplify the movement of applications and services. It is true that containers have revolutionized the application development processes. After the operating system dependency that occurred in cloud computing, today, the same technology with the containers has changed the way we store data and execute applications, since they are now much more efficient, lightweight, and adaptable to future migrations. When we are referring to a computer container, we are talking about a software solution that wraps your software process or a microservice to make it executable in all computing environments. In general, you can store all kinds of executable files in containers, for example, configuration files, software code, libraries, and binary programs. Containers in the cloud are hosted in an online environment and users can have access to them from anywhere. What is unique about this technology is that the application processes or microservices in cloud-based containers remain separate from cloud infrastructure. In simple words, the application is not bound to any cloud, storage space, or operating system resulting, which means that containerized software can execute in any computer environment. So, what is containerization all about? It's a form of virtualization where applications run in an isolated user spaces, the so-called containers we mentioned before, while using the same shared operating system. In other words, it is the process of building software applications for containers. There may be many similarities between containers and virtual machines, but they function in different ways. The main difference is that virtual machines use hypervisors, which is a type of computer software, firmware, or hardware that creates and runs virtual machines on a host machine, such as a server or a laptop, that bind them directly to the server hardware. On the other hand, applications in containers can run directly on the host operating system. The fact that applications in a virtual machine need a guest operating system per application for execution gives an edge to containers in modern IT infrastructure. As happens in containerization, traditional virtualization allows for full isolation of applications, so they run independently of each other using actual resources from the underlying infrastructure. Despite this similarity, there are some important differences. First, there is a significant overhead involved, since in virtualized deployment, each virtual machine requires its own guest operating system, plus the need for a hypervisor, an extra layer between them and the host. Then, the existence of the hypervisor itself incurs additional performance issues. Due to the overall resource overhead that could easily run several containers, it could struggle to support a single virtual machine. That said, it is clear that containerization has several benefits. Containers are simpler to set up, requiring fewer system resources than virtual machines, as they do not bind operating system images to each application they store. The necessary developer tools are universal and easy to use, allowing for the quick development, packaging, and deployment of containerized applications across operating systems. A container does not require a full guest operating system or a hypervisor. If one fails, then other containers sharing the guest operating system won't be affected, since the containers are infrastructure independent. With containerization, there is excellent probability across digital spaces because you can smoothly migrate and deploy containers anywhere. Furthermore, there is easy scaling and development since the specific technology allows gradual expansion and parallel application testing. Despite all the above, today's digital workspaces commonly feature both virtualization and containerization with the common goal of making scalable and available applications to employees. Closing this module, referring to some applications and services that are commonly containerized, such as web servers, microservices, and databases, we need to highlight that the Composable Company has the business architecture of the future. Since there's a lot of experts' knowledge in any industry and the digitalization process is evolving exponentially, modularity, with all its characteristics, will be the trend for the years to come in the business world.